Welcome to building CI/CD pipelines with GitLab. This is an In Rhythm You Lightning talk, and my name is Parag Katkar. In this talk, we will understand what CI/CD is, why we should use CI/CD pipelines, and then we will build a CI/CD pipeline with GitLab. CI stands for continuous integration. It's a software development practice where members of a team integrate their work frequently. On every code push, this integration is verified by an automated build supplemented with other checks like automated tests, code coverage, linter, and more to detect integration errors as quickly as possible. This approach leads to significantly reduced integration problems and allows a team to develop cohesive software more rapidly. CD stands for continuous delivery or continuous deployment. It's a software release process to get changes of all types, including new changes, configuration changes, bug fixes, experiments, into production safely and quickly in a sustainable way. Once you have CI and CD in place, the deployable unit path is called a CI/CD pipeline. You can see an example pipeline here. CI/CD pipelines automate steps in the software delivery process, such as initiating code builds, running automated tests, and deploying to a staging or a production environment. They remove manual errors, provide standardized development feedback loops, and enable fast product iterations. Now let me show you how to build a CI/CD pipeline with GitLab. I have created a project in GitLab which can be used as a starter kit for creating a CI/CD pipeline. You need to start with creating a YAML file named gitlab-ci.yaml in the root folder of your project. On every code push to your repository, GitLab looks for the GitLab CI YAML file and start running the jobs according to the contents of this file. The pipeline configuration begins with jobs. Jobs are the most fundamental element of a GitLab CI YAML file. In this project, I have configured 3 jobs: build stage, test stage, and deploy stage. Each job is run independently of each other. Stages is used to define stages that can be used by jobs. You can see here how jobs are using stages. It allows the creation of multi-stage pipelines. The ordering of the elements in stages defines the ordering of the execution of the jobs. I have one job per stage here, but a stage could have multiple jobs associated with it. Jobs of the same stage are run in parallel. Jobs of the next stage are run after the jobs from the previous stage complete successfully. Script is the only required keyword that a job needs. It's a shell script that is executed for the job. It can contain a single command or several commands using an array. Before script has the set of commands that are executed before the job. After script has the set of commands which are executed after the job. Now let's see what each job is doing. I have kept it really simple. The build stage creates a dist folder and copies the HTML files from the root folder to the dist folder. And it logs messages before and after the script runs. Artifacts parameter has the list of files and directories to attach to a job on success. The test stage tests if the index.html file exists in the dist folder. In a real world scenario, you would have a script to run your test suite here. Finally, we have the deploy stage, where the dist folder is deployed to an AWS S3 bucket for static website hosting. In order to do that, I'm using the AWS CLI library provided by Amazon. Now, instead of installing the AWS CLI on the default Docker image, you can speed up the process by using a Docker image with pre-installed AWS CLI. You can do that by specifying the image like I have done over here. The image keyword is the name of the Docker image the Docker executor uses. The AWS command expects you to provide AWS credentials. The credentials can be added as variables in the GitLab CI YAML file, like the bucket name variable here. But the best practice is to mask the credentials and save them as environment variables for the GitLab project. Let me show you how to do that. You need to go to settings, CICD, and there is a variables section over here where you can define new environment variables. So you can see I have already defined the variables for AWS credentials over here. Let me also quickly show you the AWS setup. You go to your AWS account and then you go to S3 and you need to create a bucket over there to host the HTML files for the static website. I've created this bucket named CICD Playground. You can see, just going back to the YAML file, I have configured the name of the bucket in the YAML file. So that's how GitLab knows where to deploy the files. Now let me also show you how to create the credentials on AWS. You need to go to IAM, users, and then you need to add a new user. I have created a new user named GitLab CICD. Then you need to attach a permission policy to give access to S3, which I have done over here. Then you go to the security credentials, and that's where you create an access key, which needs to be configured on GitLab. All right, let's go back. Going back to the YAML file, the only parameter limits when the jobs are created. Here I'm limiting the deploy job only to commits on the master branch so that the commits to feature branches are not automatically deployed to the S3 bucket. Now, this is a simple pipeline. In a real world scenario, before the code is pushed to production, most of the times it gets deployed to one of or more staging environments. In such a scenario, you can use different jobs for different environments by using the only parameter. Now, let's make a code change and see how these jobs run in action. Before I do that, let's check the HTML page. So this is a simple HTML page with just a header. And let me go to that HTML. Okay, I'm going to make a quick change. Changing the header. And I'm going to commit this change. Now, there are multiple ways to check the status of your pipelines and jobs. You can click on this icon over here to go to the job running. So this is the pipeline, right? We have three jobs: build stage, test stage, and deploy stage. You can hover over the job. Here it says build stage is running. I'm going to click on that. By clicking on the job status, you can see the log for that job. This is important to diagnose why a job failed or acted differently than you expected. So it's preparing the environment right now. Okay, so it created the disk folder. It copied the files to the disk folder. The job is successful. You can go back to the pipeline. Now it says that the test stage is running. Let's go and check it out. While the image is being created, I'll show you some other ways how to check the status on the pipeline. So you have a pipeline link on the left, which can show you the pipeline. There is a jobs link that you can click on. You can see the individual jobs. You can also go to repository and commits, where you can see all the commits you did. This is the last one that we did. And then you can see the status of the jobs. You see that the tests have passed. You can go to the test stage, see the logs, and then you can go back to the pipeline. Now the deploy stage is running. It's preparing the Docker image. Started the deployment. It has uploaded the HTML file to the S3 bucket, and the job is successful. You go back to the pipeline, you can see it's been successful. Now let's see if our change is reflected on the site. I'm going back to the site. I'm going to refresh the page, and you see the change has been reflected over here. So this concludes the demo. Let's go back to the slides to sum it up. CI/CD improves velocity, productivity, and sustainability of software development teams. Teams can respond faster to changes in the marketplace. CI/CD eliminates the tedious and repetitive tasks. It leads to happier teams that last longer and produce better products. I hope you all learned something new today. I encourage you to learn more about CI/CD and improve the way you build software.